From the Max event in Nashville, Tennessee, this is Assembly Audible, where we connect great ideas and product assembly to you. I'm your host, JJ. Today we're taking a look at a corner of manufacturing where precision and safety aren't just important, they're mission critical. In defense applications, especially those involving energetic materials, the equipment on the floor has to perform with extreme consistency while operating in hazardous environments where the margin for error is essentially zero. Joining me is Stephanie Price from PROMESS, who's working at the intersection of servo press technology and defense manufacturing. We'll talk about what's driving the shift away from traditional press systems, what it takes to engineer equipment for explosive environments, and how manufacturers are balancing control, safety, and reliability in these demanding applications.
The processes needed to be very controlled, especially when it came to energetic powder compaction, right? High explosive powder, also known as HE. But the equipment that they were being used, or they were using to do it, didn't have the same controllability as current technology out there, like servo presses. So we took that information, took it back to our development team and said, we need to help here, right? We need to allow our industrial base to have the same technologies for their facilities as what we're using in automotive. So when working with the energetic material, a lot of that is done in an area, a C2 Div 1, so Class 2 Div 1, which means there is significant amount of energetic powder in the area and in the air. And so you need to make sure that the equipment that you're using is intrinsically safe so that none of the particles can ignite on a warm component or an energized component for that area. And that is one of the reasons why for so long, right, we didn't change our technology from hydraulic or from pneumatic because those technologies are intrinsically safe by nature, right? Because they're not using a servo drive or a servo motor. So having that information, we went back to our development team and said, okay, how can we make our servo press intrinsically safe? How can we make our servo press able to be used in those areas so that they can have more controllability, so that they can have better programmability for those applications? The density of that powder when it's compacted is really important for the safety of the material. So it has to have the right porosity, okay? The powder itself has like a thin binder around it, which kind of melts. And in order to have that powder melt and the powder pieces to have the right density, you have to have very fine control over how you're pressing and holding that powder. That was a challenge when you're doing it with valves and controlling it through hydraulic fluid. With a servo press, you can program the system to whatever force is needed, right? And very slowly, the press itself will regulate down to the desired force and hold it so you can get that right density and you can get that right quality for the powder, for the compacted powder.
Tell me about the real-world impacts of switching to servo presses.
So outside of really having better control over that process and having better part quality and having the right density, now you're able to get a more complete picture of your part because you're seeing the feedback from the encoder on the electric motor. Our servo presses have integrated load cells, so now you can see the force what the powder was at, and you can make sure like, okay, yep, we came down to the desired force, because if it comes down to the force too fast, it doesn't give that binder enough time to melt, and you're not going to get the right density, you're not going to get the right porosity. And And so just having that data now is something that most systems that they have in the field, they're not getting.
The H-Press series, as we've been discussing, can be used in hazardous locations. But I imagine from an engineering standpoint, that took a lot of tweaking and adjustment on your end. Tell me about what changes you needed to make in order to make this a reality.
So the first thing we had to do is we had to look at the motor that we were using. And we have a partnership with Elwood who makes intrinsically safe servo motors. And so we swapped out the servo motor that we were using to an intrinsically safe servo motor. We had to look at the design of the press itself. Most of our presses are in what we call a parallel configuration. So we have a belt and pulley from the ball screw to the servo motor. But for the H series, we put it in what we called inline. So the the ball screw is directly attached to the motor with a coupler, right? So they're inline. And that was done because in the parallel configuration, you would have a flat top for where the hood is between the servo motor and the ball screw press. That was a collection area for the powder. So we wanted to minimize the amount of collection areas that they had. The press itself is completely sealed with a small filter that would have to be changed probably once a year when you do your calibration. But you don't want any powder getting inside of the press. And then we had a double wiper at the end of the press rim so that there's no grease that comes down, because one of the maintenance item with the servo press is that it needs to be greased. Probably we recommend every 3 months for a defense application. So, and then the feedback cable and the motor power cable, they have to be hard piped into the electrical cabinet, which is normally kept in an inert area. The digital signal conditioner, which is where our sensor feedbacks go into, those wires go into an intrinsically safe barrier, which is inside an explosive box. And then that was it. It was a few things that we needed to do, but it was a fun project to work on with our development team, and it was fun to work on something that there was an immediate need for, and that it's something that this industry has just been craving, but they've not had the technology for it. Overall, the technology that's going on in the defense industry is really fascinating. I was just recently at a defense show, and we were talking with a manufacturer who is doing 3D printed jet engines. And we were having a conversation about the technology now and how it is going to change manufacturing in the future, and just people are going to be able to print replacement parts, right? As opposed to maybe necessarily going to the AutoZone, or maybe even AutoZone will have the 3D printers, right? So you give them, they look up the CAD file for what they need, and they'll 3D print the part for you. I mean, it's just exciting. It kind of reminds me of the Industrial Revolution, only it's more of a technology revolution for our defense industry.
Stephanie, thanks so much for sitting down with us and talking today. It's been a great conversation, and a special thanks to all of you, our listeners. I hope you'll tune in again soon.